Hey folks, welcome back again. So in this video, we will be talking about Python sets. So let's talk about the definition first. So sets are unordered and sequential. So it stores the unique elements. There is no duplicacy. Though we add duplicate elements to it, so it won't keep that elements. And it is mutable, so we can add and remove elements from the set. So unlike frozen set, these are mutable. So we can define the sets in two ways. So one is using built-in set, and the other one is using curly brace syntax. So we can do this in two ways. So let's look at that. So let me go to sets.py and define s1 equals to set of, so we need to pass an iterable here. So I'm just passing the list here. So 1, 2, 3, and let's also define the other set using curly braces, that is a, b, and c. So let's print the results s1, and let me copy this, and s2. So when we run this, so we can get the both s1 and s2. So let's run it. Python, so we are using Python 3, Python sets.py. So if we check it, like 1, 2, 3 is there, and the other one is a, b, a, c. So we can see there is no order, and so though we defined a, b, c here, we can clearly see that b, a, c. So the elements are unique. Let me define one more element here. Let me duplicate a, and let's run it again. So we can see that only 3 elements are there, though we define 4 elements in the set. So that's how we define the sets, and let's see how we can add elements to it. So we can use two methods, that is add and update for that. So let me go to sets.py, and let's add s1 dot add. Let me add my name and print s1. So let's also have one more print statement before, and s1 after s1. So let me clear it out and run the Python sets.py. So here we can clearly see that we added element ng, that string, to this set s1. So that's why we are able to see after we have one more element, and before we have only 3 elements. So that's how we add. So we can also use update to update the multiple elements to the set. So currently we have, for the s1 we have only 3. So I want to add 4, 5, 6. We can use the update method to update it. So if we use add, so we need to use that for 3 times, 4, 5, 6. But if we use update, so it will update at once. So let's see. This one dot update. Oops. This one dot update. So for this we need to pass the iterable 4, 5, and 6. So let's run it and see Python sets.py. So here we can see that 4, 5, 6 are added. So we can't do that using add method. So let's run it again. Python sets.py. So here we can see that it is un-hashable type. So we get error. So add only adds one element, and update adds multiple elements to the set. So that's how we add elements to the set. Let me clear this out. And so we can also remove elements from the set. So for that we have multiple methods: remove, discard, clear, and pop. So let's look at one by one. Just one dot remove. Remove. So we need to pass element to it. So let's pass 1 and print 1. Let me clear the console and run Python sets.py. So we can clearly see that it did throw key error 1. So that's because we didn't have the key 1. So this is string, and we have integers in the set as1. So let me update this to integer and run it again. So we can see that we have only 2 and 3 elements. So that's how we use remove to remove one element. So we can also use discard to remove the single element. Discard. Let me pass the in string 1 to it. So previously we got error, but this time we don't get that error. So we can see that it did delete, but it didn't throw the error. So because there is no element 1 in there. So that's the only difference between remove and discard. So let me replace that with 1 and run it again. So we can see that it did delete the 1 from the set. So that's how we define. Sorry, that's how we remove the elements from the set. So let's say if we want to remove all the elements from the set, so then we can use clear to remove all elements. Let me use, so we don't need to pass any arguments to it. Clear. And if we print that, so we can see that set type is empty. So there are no elements to the in the set. So that's how we use clear. And we also have one more method, pop. So what it does is, so it just removes the one element from the set and it returns it. So let's do that. Pop. Okay, let me assign that to number equals to. So let's print s1 comma number. So let's clear the console and run it again. Python H.py. So here we can see that it did remove the element one, and we can see the set has only two elements. So that's how we um, remove the element and get the element using pop. Let's look at finding the number of elements. So we can simply use Python's built-in function len to get the total number of elements in a set. So let's use that. For that, we don't need this. And let's use len function. Let's pass s1 and run it. So we have a total of 3 elements in the set s1. So if we count the number of elements in set s2, let's run it. Yeah, though, okay, let me add one more here and count it. So we got 5. So that's how we count the number of elements, and then copy set. So we have a method, a copy, to copy the set. Let's look at that. Let's define s3 equals to s1 dot copy, and let's add one more element to s3, that is 3, and then print s1 and print s2. So let's clear the console and run python sets.py. So we can see that we did add z to, oh, looks like we didn't print the s3. Okay, let me run it again. So here we can clearly see that we, for the s1 we have 1 2 3, and for s3 we have 1 2 3 and z. So we, that means like we copied all the elements from s1 to s3, and then we added one more element to it. So that's how we copy the sets. Let's look at the set operators. So we use minus operator for set difference, and pipe operator for union, and ampersand for intersection, and symmetric difference using caret. So let's perform these operations. So let me define these sets. S1 equals to 1 2 3 4, and S2 equals to A B C and 1 and 2. So let's perform difference, set difference s1 minus s2, print if. So let's run the program. So we can see that we got only 3 and 4. That's because all the elements which are in s2 were removed from s1. So that's why we have only 3 and 4. So let's perform union operation, that is for the pipe. So let's do union. So let's run it. So we, now we have all elements from s1 and all elements from s2. So we can see 1 2 3 4 and ABC here. So let's perform intersection using ampersand. Um, let's name it as common, and let's clear this and run the program. So we can see that 1 and 2. So when we do intersection, we get only common elements. So that is 1 and 2. And let's use symmetric difference. So if we use caret, so we get symmetric difference. That is other than 1 and 2, we get all elements, non-common elements. So let's check that. ST symmetric difference, and let's run it. So here we can see that we have A3 4 BC. So we didn't see a 1 and 2 here. So that's how symmetric difference works. So we covered all these set operators. Let's go to set methods. Let's talk about set method union. Um, result equals to, so we defined s1 and s2, and result equals to s1 dot union s2 in the result. So let's run the program. So here we can see that we have all the elements which are from s1 and s2. So we did the union operation here. So if we do difference, so we get the set difference, which means we will remove the matching elements from S2, the matching elements from S1 and S2. So if we see S1 and S2, we have common elements 1 and 2. So we will get the output as 3 comma 4. So let's run it and see. So here we can see that 3 comma 4. So that's because we removed S1, all elements from S2 from S1. So that's how the difference works. And let's say let's see the difference update. So if we see the difference update, let's run it. So it returned the none. That's because so there is no return, there is nothing is returning from the difference update. That's because so when we do difference operation, I mean when we use this method, so it directly updates the result into the variable s1. So instead of result, let's print s1 here. So let's run it. So here we can see that 3 comma 4. So for difference, the s1 will remain same. So let's execute it and see. So for this difference, we can see that the all elements 1, 2, 3, 4. But for difference update, it updating the variable s1. So that's the difference update. Let's talk about the intersection and change the s1 to result. So when we do intersection, we get the common elements from both s1 and s2. Let's run it and see. So we can see that there are only two common elements, 1 and 2. So here we can see that. So both S1 and S2, both sets remains the same after this operation. But if we use the intersection update, so S1 gets updated with the result. Let's run it and see. So we got the result as none because there is no return statement in the intersection update. So if we look at the S1, so we can see that 1 and 2. So though we define the 3 and 4 elements in the initial, but after this operation, so we have only 1 and 2, which are common in both S1 and S2. So that's how the intersection update works. Let's look at the other methods: is disjoint, is subset, and is superset. Let's look at these methods. So let me change this back to result and replace the method with is disjoint. So it checks the both sets S1 and S2, and if these are disjoint, it returns true. Otherwise, it returns false. Let's run it. So it is returning false because both the sets have the common elements. Let me remove 1 and 2 from S2 and let's check that. So now we did return the true. That's because we don't have any common elements between S1 and S2. Okay, let's see is subset. Let's paste the method is subset here. So let's run it. So we can see that the result is false because S1 is not subset of S2. Let's define few more elements to the S2. So 1, 2, 3, and 4. Um, So let's check now. So it did return true. That's because all the elements which are in S1 does have, S2 does have the all the elements from S1. So that's why the result is true. Um, so that's how the is subset works. And let's see the other method, that is superset. So we know that S2 is superset of S1. So let's see that is superset. S2 is superset of S1. Superset means it needs to have all the elements from subset. So 1, 2, 3, 4, all elements S2 does have the all the elements from S1. Let's run it. So here we can see that it did return the true. So let's check if S1 is superset of S2. It should return false. Yeah, we can see that it did return the false. So that's how the superset work. And let's see the symmetric difference. Okay, let me paste it here. S1 symmetric difference S2. Let's print the result. So it should get the symmetric difference. It should remove the all common elements, and it needs to have only uncommon elements from S1 and S2. So for this, we need to have the elements 5 and ABC. So let's run it. So here we can see that 5 and ABC. So that's how the symmetric difference works. Okay, let's look at the next method, that is symmetric difference update. Let me run this. Python sets.py. Yeah. So for this symmetric difference update, it S1 gets updated with the result, and it didn't return any result for this method. So let's print the S1. That's because we are performing the operation on S1. So let's run it and see. So the result is updated in S1 variable. So yeah, that's how the symmetric difference works. So when we use the underscore update on all the methods, so the first variable that whatever the variable that we are using, that gets updated with the result. Yeah, so these are the all set methods. Um, we can use the sets whenever we need the unique elements and non-order, whatever the definition that we have. So in that cases, we use the sets. If you like this video, please do hit like button, share, and subscribe to my channel. Thank you.